Hello students, I am Raghuraj Singh, Assistant Professor in Computer Science and Engineering Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss the topic that is called the concept learning. So many of the times I have also faced some difficulties about the concept about the concept learning. There is no any direct approach which is available in the different books. Some different books, different online resources are available, but they are not providing the some clear cut concept about the concept learning. So that's why I thought about the discussion about this complex topic that is called the concept learning. So today lecture is going to be very interesting just because of the reason that I have clearly mentioned the things about the concept learning, what is concept learning, what is the inductive bias in the concept learning. So what are the different attributes that can be semantically, synthetically can be calculated, and how what are the different algorithms that can be used to find out the concept about the concept learning. So we will discuss here find us algorithm, candidate elimination algorithm. These are the different algorithms that are available in the concept learning. So let's start here. Very first things about the concept learning. So what is the concept learning? In very first lectures, in very first thing that need to be described here, that what is the meaning of the concept learning, what is the concept learning. So very formal definition of concept learning is defined as inferring a Boolean valued function from training example of its input and output. So from the any available set of training instance, if we are able to infer, if we are able to conclude some concept, some decision about the input and output, that is called the concept learning. So it in a very simple way, it can be defined as inferring a Boolean valued function. Boolean valued functions may be in the form of either yes or no, either positive or negative, either true or false. These are the called as, these values are called as the Boolean valued function. So if we are able to define, if we are able to infer, if we are able to conclude a Boolean valued function from the training examples, from the given set of training example, that is called the concept learning. So in very formal way, it can be again defined as concept learning is a learning task in which we train our machine to learn the some concept. So this particular line is describing the actual definition of the concept learning, that what is the concept learning. Concept learning. So concept learning can be defined as the learning task in which we train our machine to learn the some concept. So the concept could be either yes or no, either positive or negative. So that kind of Boolean valued function, if we are able to conclude, then that is termed as the concept learning. So an example of concept learning is the learning of bird concept. So in this particular things, I have taken an example, a very simple examples which could define the basic concept of the concept learning. So I have taken example that is that to describe the concept learning is a bird concept. So from the given example of birds, so positive examples. So if the given attributes belongs to the category of the birds, then it is defined as the positive examples. If it is doesn't belong to that category, that is called the bird category, or if it is belongs to the non-birds category, then it is termed as the negative examples. For example, data set we have given here, data set is equal to parrot, sparrow, cat and dog. So in this particular data set, there are 4 attributes. So out of these 4 attributes, parrot and sparrow belongs to the birds category, but cat and dog doesn't belongs to the bird category. So here parrot and sparrow belongs to the birds category. So it is called it is said to be as the positive examples, while cat and dog doesn't belongs to the birds category. That's why cat and dog are the negative examples. So we are trying to learn the definition of concept learning concept from given examples. So this is the kind of the scenario from given examples we have seen here as a data set, where we have seen that there are 2 type of instances. There are positive, some are the positive instance and some are the negative instance. So positive instance are those which defines the concept, which fulfill the requirement of the concept, and negative examples are those which doesn't fulfill the concept of the requirement. So cat and dog doesn't belongs to the bird category. That's why it is a negative examples. While parrot and sparrow belongs to the birds category. That's why it is to be defined as the positive examples. So in basically in case of the concept learning, we learn the definition of concept from the given examples. So from the given examples, we basically try to learn the concept, that is called as the concept learning. So very second point, in second point is clearly defining the definition of the concept learning. That is concept learning is a learning task in which we train our machine to learn the some concept, for example, yes or no, positive and negative. So clearly this particular lines defines the concept learning. So concept learning task, enjoy sports training example is given here. So this kind of attributes in the, will be given in the case of the concept learning. So out of these given attributes, we will define here what are the positive attributes, what are the negative attributes. So for the first training instance, for the first training examples we see here, there are different attributes given here, that is sky, air temperature, humidity, wind, water, forecast, enjoy sports. So enjoy sports is basically a concept. So in PPT it is very clearly has written here. So all these attributes are defined to be as the attributes. All these parameters are defined to be as attributes, and this particular last column defining the enjoy sports is defining the concept. So what concept is to be drawn out of these different various attributes, that that concept is listed here in the last column. So in very first examples, we are basically very first example, we are basically defining the yes concept. Enjoy sport is value of enjoy sport is yes. So value of enjoy sport is yes, then it is to be termed as the positive examples. If value of again second examples, again giving the value that is yes, again it is a positive examples. But very third attributes out of these deducing the concept from out of given these parameters, the value of the concept is no. So basically this particular no is defining the concept of the negative examples. So it is the third instance, third training example is the negative training examples. And again fourth training examples, that is sunny, warm, high, strong, warm, change, again defining the concept, that is yes. That's why it is again a positive training examples. So in the case of the concept learning, the attribute should be given here, different attributes should be given here. Out of those attributes, we will deduce the some concept. So concept can be the Boolean valued function, Boolean valued parameters. So Boolean valued parameter basically defines the concept, that is called the concept learning. So we will able to take the some decision. If we are able to take some decision, then it is to be termed as the concept learning. So a set of example given in the tables where days, and each is described by 6 attributes. So each in every training examples are defining having the 6 attributes, that is sky, air temperature, humidity, wind, water, forecast. So if we count here, this is first attribute, this is a second attribute, this is third attribute, fourth, fifth and sixth. So these are the 6 attributes. So out of these 6 attributes, we are defining the concept, that is enjoy sport is the basically concept. This is the final result that we are deducing from the different parameters, that is these are the 6 attributes. So basically here the task is to learn to predict the value of enjoy sports for arbitrary day. For any arbitrary day, we will deduce the concept that whether we can enjoy the sports on particular day or not out of the available attributes. So enjoy sport is the enjoy sport is basically the defines the hypothesis representation, which where value we used are the different training instance. So different training instances are defining the one hypothesis. So each hypothesis consists of conjunction of constraint on the instance attribute. So in different training instances. So here there are we having the 4 training instances, that is 1, 2, 3 and 4. So these 4 training instances are basically defining the different attributes. So different attributes are defining the different hypotheses. So basically each hypothesis is basically consisting of a conjunction of constraints. So conjunction of constraints is what? So whatever the concept that we are learning from these 6 attributes. So these 6 attributes are defining conjunction of these 6 attributes, that is sky, air temperature, humidity, wind, water, forecast. So these are the 6 attributes. So conjunction of these 6 attributes are defining the concept that is giving the value as a result. So that is what has been told here in said in this particular point. So basically each hypothesis consists of conjunction of constraint on the stance attribute. So each hypothesis will be a vector of 6 content, that is specifying the value of the 6 attribute. Attributes are already we have seen here: sky, air temperature, humidity, wind, water, and forecast. So each attribute will be here we are formally defining the concept learning, that each attributes will be denoted by question marks. That denotes what? That indicates any value is acceptable for the attributes. So if any value is acceptable, so we don't need to don't care. So that is called the don't care conditions. That is called the don't care attributes. So if it is accepting the single value, a specific value, so if it is specifying a single required value, that is for example, that if a specific value is warm, so this is value is warm, then it is specific attributes. So for that we need to define a value that is called phi. That means that indicates that no value is acceptable for the attribute, that is no value. So it defines that the value of that particular attribute is fixed and no other attributes are acceptable in place of that specific attributes. So for that particular attribute we can define the value that is called phi. So phi basically indicates that no value is acceptable for the specific attributes. So this is the way that how in case of the concept learning, how we represent the hypothesis, how the representation of the hypothesis should be carried out. So hypothesis representation, any hypothesis can be represented in the way as shown here in the screen. So we will use the closing, opening and closing braces like less than and greater than sign symbol. So within this, when we are defining any hypothesis in case of the concept learning, we will always use this particular symbols, that is the opening and closing symbols. So in this particular symbols we will list out the all different attributes. So all different attributes are what? These are the sky, air temperature, humidity, wind, water, forecast. So these are the different 6 attributes that are available in our data sets. So if the values are having the any kind of value, if values are acceptable, that is any value, that will be specified by question marks. So question mark is basically defining that any value is acceptable, no specific value is taking on in this particular instance. So the question mark should be used here. So the most general hypothesis, so in the case of the concept learning we will use two special kind of the attributes, the special kind of the expressions, that is called the most general hypothesis. So most general hypothesis should be represented that every day is a positive example. If every day has positive examples, then definitely will be that it can take any value. It can be the attributes doesn't depend on the value, concept doesn't depends on this value. So if it means the value is not depending on these parameters, so that it can take any value. That's why we have represented here with the help of the question marks. So the most specific hypothesis, that no day is a positive example. So if no particular day is a positive example, then again it is taking some specific value. So there is a value is fixed. So if values are fixed, then value which should be denoted by 5 symbols. So 5 symbols, that is no day is positive example, no day is a positive example. So these particular two things, that is most general hypothesis and a specific hypothesis, should be take care should be especially take care in noted to be in mind, that when we are going to discuss any kind of hypothesis representation in case of the concept learning, when we are going to apply the finders algorithm, when we are going to solve any data set problem with the help of the finders algorithm, candidate elimination algorithm, then definitely we will be going to use this general hypothesis and a specific hypothesis. So, basic representation of general hypothesis and a specific hypothesis that defines the movement of the attributes from general to specific and specific to general. That we will discuss in the detail in the algorithms, candidate elimination algorithm, as well as in the case of the finders algorithm. So, enjoy sports concept learning task requires the learning the set of days. So, enjoy sport concept learning task is basically what that requires the learning the set of days for which enjoy value of the enjoy sports, that is the concept that we need to take care here, that value of enjoy sports should be equal to S. So, that describes the set of conjunction of constraints or the instance attribute. So, in particular data set, whatever we have the 6 different attributes. So, these 6 different attributes are defining the combinedly producing the target result, target concept, that is either value is either yes or other value is no. So, this target concept we are learning from this particular learning task, that is we are obtaining by implying the conjunction of constraints, different constraint that we have 6 constraint here. So, combinedly 6 constraint are giving the value of the concept. So, enjoy sport concept learning task is given, whatever the data set is given here, that consists of instance. Instance is the what? The set of all possible days is described by the attributes. So, set of all possible days which are defining the attributes. The values are, first value is what? Sky. So, sky having the values that is sunny, cloudy and rainy, sunny. So, these are the 3 different attributes that were consist by the sky attributes. The second attribute is air temperature, that is defining two different attributes as we have already seen in the table, data set table, that is value is warm and cold. And again the value air temperature. So, again air temperature having 2 values, that is the warm and cold. So, warm and cold are defining the 2 different attributes. So, warm and cold are 2 different attributes. Humidity again is giving 2 different value, that is normal and high. So, attribute humidity has 2 different value. Attribute wind has 2 value, that is strong and weak, and water having 2 value, that is water and cold, warm and cold, sorry, and forecast has 2 value, that is same and change. So, these are the different 6 constraints that are defined by that having the different value. So, we have already seen the data sets, and the data sets, these are the different attributes. These different attributes are defining the different values, that is that are producing the concept, that is target concept. So, target concept is what? Target concept is what? Target concept is nothing, that is the concept that we are learning from the training instance. So, training instance we have here. Training instance we have here consisting of 6 attributes, and all these 6 attributes having the different value that we have seen here. Sky, first attribute is sky, which having 3 different values, sunny, cloudy and rainy. Air temperature having the 2 different value, warm and cold. Humidity having the 2 different value. Wind has 2 value, water has 2 different value, and forecast again have 2 value, that is same and change. So, target concept is what? The attribute that we are getting from the conjunction of the 6 constraint. 6 constraint we have seen here. These are the value that we get, that is produced as either yes, and other value is what? That is the no. That is the concept. That is the concept that we are learning from the training instance. So, that is the concept. So, that is called the concept learning. So, target concept is function is what? If we represent in some form of the function, that function f such that x tends to y is producing what? So x tends to y is producing what? This particular function can be described by having the value that is either 0 or 1. So whatever the value we are getting, we can consider it that is the there is some function, because we are using here the concept hypothesis. So what hypothesis is representing here? That is defining some form of the function. So function C, that is concept, and concept is what? Enjoy the sports, that having the value that is either x such that x tends to 0 or 1. So value of x is what? Value of x is representing some concept. So value of concept is either 0 or 1. So 0 is representing what? Training negative training example, and 1 is representing what? Positive training examples. So this 0 and 1 is the basically the notation of the negative training stance and positive training stance. So training example D. So data set we have D. So that is defined as training example D, having the positive and negative examples that are defining the target function. So target function and target concept is defined by the these two different attributes. These are called as binary valued attributes. So stance is what? In the case of the we are discussing again that we have the different instance. So basically what the concept is defined by the instance. So instance is basically nothing, it is the set of items over which the concept is defined, is called the set of instance. The set of items that might means different attributes that is employed by the different parameters, that is the set of items over which the concept is defined, is called the set of instance. Target concept is what? The concept or functions to be learned is called the target function. Concept or functions to be learned is called the target concept. So that is called the that is the concept that is learned by the training examples. So concept or functions to be learned is called the target concept, which we denoted we denote by C. So basically C defining the concept that we are learning from the training examples. So in general, if C can be any Boolean value functions defined over the instance x such that that is C, that is the concept that is learned, that is defined by the value x. So x having the value that is 0 or 1. So in the current example, the target concept corresponds to the value of the attribute enjoy sports. So this can be mathematically represented as in the concept learning Cx is equal to 1 if enjoy sports is equal to x. That means concept learning over the task x is equal to 1, that means is producing the positive training it is the positive training example. If enjoy sports, Cx is equal to 0 if enjoy sports, that denotes that enjoy sports is equal to no. So this kind of the values, if we are deducing from any training instance, from any training examples, that defines the learning concept. So learning concept is here what? Nothing, it is the value, simply Boolean valued functions. So we are taking the decision that whether it is a positive training example or whether it is the negative training examples. So out of these positive and negative training examples, we will apply the concept of the different algorithm, that the algorithms are find dash algorithm and candidate elimination algorithm. So what are the in the next in this particular slides we will see what are the inductive learning in the hypothesis. So any hypothesis, so how inductive learning can be defined, how inductive learning can be we can explain. So basic explanation of inductive learning hypothesis can be defined as any hypothesis that is found to approximate the target function well over sufficiently large set of training examples will also approximate the target function well over the other unobserved examples. So basic meaning to say this particular definition is that if any hypothesis that is approximating the target function, that is approximating the target concept sufficiently over the large set of training examples, then it will be also able to approximate the target function well over the other unobserved examples. There should be a new training instance. If our hypothesis that we have taken into consideration, if it is producing the target function well over the training examples, then it is also expected that if it is able to approximate the target function well over the other unobserved example, that is called the inductive learning hypothesis. So in that, basically we will define here concept learning as a search. So how the searching should be carried out, how the basic calculations should be carried out. So we'll see here. So concept learning as a search can be defined as, can be viewed as the task of searching through a large space of hypothesis. So if we have the different attributes, so we have the different training instance. So out of those training instance, what the concept we are deducing, what the concept we are learning, that is defined as Boolean valued function. So if Boolean valued, Boolean valued function we are getting from out of those training instances, that is called the concept learning as a search. So goal of this search is to find the hypothesis that best fits the training examples. So basic objective of this particular searching technique is that why we are using concept learning as a search. That so we so what basic concept could be drawn, what basic conclusions should be drawn out of the available training instances, that is called the concept learning as a search. So goal of this search is to find the hypothesis that best fits the training examples, that is called the concept learning as a search. So in continuation to previous slides, by selecting a hypothesis representation, the designer of the learning algorithm implicitly defines the space of all hypotheses that the program can ever represent and therefore can ever learn. So this particular point is describing the how we basically carried out the representation of the hypothesis, and what the concept will be drawn from the that hypothesis, that can be described by this point. So basically the mean to say that by selecting a hypothesis representation, if we are representing the hypothesis, so by selecting the representation of the hypothesis, the designer of the learning algorithm that implicitly defines the space of all hypotheses, that with the help of those hypotheses, representation of those hypotheses, every representation of the hypothesis represents the one concept that will produce one concept. So each and every hypothesis, combination of each and every hypothesis is defining the hypothesis space. Collection of all those hypotheses is called the hypothesis space. So in joy sports that we have already taken into consideration this particular examples. So how the hypothesis space could be represented. So sky has three possible values. Sky has the three possible values and other five attributes have the two possible values. So how we will be able to calculate that how many number of distinct instances in the X. So X is defining what? X is defining the training examples. So in this particular training examples, there are how many distinct instances are available. So if you want to calculate that, so we will simply see that that first attribute sky has three different values and other five attributes having the two different possible values. So total number of distinct instances can be calculated as equal to different multiplication of different training instances. Multiplication of different instances are first attributes having 3 value, second attributes having 2 value, and others attributes are also having 2 value. So multiplying 3 into 2 into 2 into 2 into 2 into 2. So these are representing the different distinct instances in the data set X, that is should be equal to 96. There should be 5120 syntactically distinct hypotheses in the hypothesis space. So basically already we know that we have two hypotheses, positive and negative. We had two different type of hypotheses. First hypothesis category of hypothesis is either positive, and second category of hypothesis is either is negative. So we have the two different outcomes for each and every value. So different values are what? Different values are 3 for the first attributes, two different values are possible for the second attributes, and others possible attribute also having the two different values. So each and every attributes are defining the two possible values, that is either positive or negative. So we will add these two extra values into the attributes, that is first attribute having value 3, so 3 plus 2 is equal to 5. Again other attribute having two different value, but we are defining into two different values, that is either positive and negative. So 2 plus 2 is equal to 4. So every value becomes to 4. So we are after considering the positive and negative example and adding it into the attributes, because each and every attributes are defining the two different attribute value, that is positive and negative. So positive and negative are also combined into the training instances. So we will add these two value into the number of attributes. So first attribute having value 3, 3 plus 2 is equal to 5, 2 plus 2 is equal to having 5, 4. Another attribute also having the value 4. So multiplication of these 6 instances are said to be as the syntactically distinct hypothesis in the hypothesis space H. Just because that we having the two hypotheses, that is positive and negative. So it can classify every instance as negative. So we are defining the third category of the semantically distinct hypothesis in the hypothesis space H. So every hypothesis contains null value. So it may be possible that every hypothesis can have some null value, that is the specific instance. If value is fixed, then every hypothesis must have some null value. So if we have the null value, so what could be the possibilities? So possibility could be that 1 plus 4 into 3 plus into 3 into 3, that simply we are defining the one as a null attributes, and others are the value that has been added as a 3 plus 1, 2 plus 1, 2 plus 1, 2 plus 1. So 1 plus 1 is the special value, that is null value, and 4 into 3 into 3, that are calculation of this particular value, that is equal to 973, that gives the semantically distinct hypothesis in the space, hypothesis space H. So only one more value for attributes, positive and one hypothesis. So one is for one that has been used here, that has been considered for the null hypothesis, that is representing the empty set of instance. So although enjoy sports has a small finite hypothesis space, most learning tasks have much larger even infinite hypothesis space. So we need efficient search algorithm on the hypothesis space. So in 2D lectures we will conclude up to this part. So we have in 2D lectures we have learned the basic definition of the concept learning, how the concept learning is defined, how the hypothesis representation should be carried out, and how what are the different distinct hypotheses, what are the different semantically distinct hypotheses, what are the different syntactically distinct hypotheses, calculation of all these different hypothesis representation we have seen here. So in the subsequent lectures we will talk about the different concept learning algorithms like the find us algorithm as well as the candidate elimination algorithm, and how the hypothesis representation should be carried out with the help of the find us algorithm and the candidate elimination algorithm we will see in the next lecture. So for today, thank you.